Would you be able to all reintroduce yourselves quickly with just a couple of words so that we can be reminded of where you sit in this ecosystem?
Yeah, sure. I'm Chris Coates. I'm the Head of Engineering for HPC at Logicalis, who are a supplier.
Hello, I'm Stig Telfer. I'm CTO at Stack HPC, working in research computing and cloud infrastructure.
Hi, I'm Emma Barnes. I'm Head of Research and Faculty IT at the University of York.
Steve Hydemarsh, Head of Research Computing at the Norwich Bioscience Institute.
Chris Edsel, Head of Research Software Engineering at the University of Cambridge.
Great, thank you very much. Well, I've got a question, start for 10. Get things kicked off. Chris, given your point that software is a key area that we should be focusing on to have an impact, what did you think that we should be doing immediately? Is it more training, more RSEs, or do you think that would be something else? And that question is obviously open to the whole panel.
Both of those things would be good, more training and more RSEs. We have a lot of RSEs. I mean, we've been saying we need more RSEs for 11 years now. Eventually somebody's going to get tired of that, but at the moment people seem to be seeing the value. And you know, it's a very easy value proposition to make when you say, you know, we looked at this piece of code, we made it 20% faster, you know, emitted so many tons less CO2. That's a valuable thing. So I think we need more awareness on the problem. So we've got a very good awareness in the community about sustainability in the sense of longevity of software, you know, ease of use of the software, etc. The environmental sustainability piece hasn't been developed as much yet. So I think there's some internal training needs to go on in the RSE community about that, what tools are available, what we can do there.
Anybody else on the panel?
So I would quite like more RSEs because we don't have enough at the University of York, and I think there are some universities that are just further ahead than us, and we're trying to play catch up. But I think training is a huge part of it. We've got a lot of sort of areas, academic areas and disciplines where they've not really used computers for their research before, and they're coming into this era, and it would be good if we from the outset grab them, train them well, and you know, we don't have to necessarily go back a step in that regard. So, but I do agree, training, and I would like more RSAs, but I don't have enough.
I think it's a really important point. And in particular, this idea that software engineering, research software engineering is included in that. It's just so much more than programming. I mean, programming is stuff that, you know, coders do in their bedrooms, and they don't actually really do very much in terms of the professional practices or the supporting components which enable them to deliver software as part of an effort, as part of a team, and correctly, and so on. And maybe the RSE initiative, I mean, I couldn't agree with it enough, really, in terms of what is needed there. Just to be able to provide better software with fewer mistakes, fewer iterations, and greater degree of testing and correctness. I mean, all of these components will actually enable people to get their job done with less energy, and probably less frustration too. And a lot of what Chris was just talking about in terms of building in these sort of DevOps skills and these cloud native skills, that is just going to augment all of this this training and this skill set. So I think it's really important to be able to bring these things. I can't support it enough, really.
Yeah, so I totally agree, right? So I think coming at it from kind of a different angle, I think the tools that we use probably need to be better, right? Because if the tooling that we use is better, then the arguments of we need more people probably go away a little bit. Not as much. I mean, we still need more people, right? But if our tooling can automate a lot of the menial processes that we talked about, you know, in the previous presentation, then I think that will help. So coming in from a different angle, I think it is people, it is process, and it's tools as a holistic thing. Because if we just throw more people at it, we'll still be in the same situation we're at in a couple of years' time, right? When we have to support 6 architectures and heterogeneous environments, and we'll just be kicking the can down the road. I think we've got to also change our processes and our tools.
Yeah, and perhaps our education at undergraduate level and focus more on development skills and on compiler languages and those kind of basic DevOps skills, so that the quality of the code that is coming through at the early PhD stages is more efficient and effective. So it'd be nice to open the floor up. Anybody got any questions about what now? Sustainable computing. Lovely.
Not really sustainable computing, but
Sorry.
I think the RSA movement has been marvellous. In particle physics, we used to have physicists and programmers, which was done. Because Chris said, whoever went into HPC to do firmware upgrades, my bet is that most of us here are not computer scientists. We got here because when we see a problem, we'll go and fix it. And in traditional IT departments, people who have the skill, should have the skills to do that, just won't do it. As a for instance, I've seen many cases where two Cisco switches are spec'd at the top of the rack. The reason for that, what was known from Cisco here, the Cisco salesman says we need them. And there's no thought given to it. And you get an HPC system that comes in with an InfiniBand switch. So, well, I know nothing about InfiniBand, I'm not going to touch that. I didn't know anything about InfiniBand day one when one arrived in a system I was installing 20 years ago. But I got the manual, I got busy and read up on how it operated and how subnet manager works, and gained some competency on it. And I think that's the difference between HPC and traditional IT departments. What would you think? Sorry.
No, absolutely right. So it probably makes more sense to give me a bit of background for myself, right? So I was a reverse engineer, right? A hacker, and my insistence on wanting to know how things worked got me into the industry. I think we focus a lot on kind of qualifications and not enough on initiative. Because I know loads of people with qualifications that don't necessarily have the initiative to go and dig into the real fundamentals of why. And from my perspective, I think we're missing a trick. I think there are loads of people out there that have that initiative that we kind of completely overlook because we put requirements on roles that must have a PhD, right? And we're missing so many people.
How do you suggest we communicate that message?
I think part of it is actually just going to, so we talk about the cluster challenge as an example, right? So the cluster challenge is actually a fantastic idea that probably gets underutilized because there are so many people there that have amazing talents, but I'm pretty sure hardly any of them get job offers. But it's a perfect interview process. You get to see them up close and personal working on something that's live. They're the kind of people we should be looking to attract because they're already doing it and you can see them in an interview process directly, regardless of whether they have the qualifications or not. They're the people we should be trying to fast track into those roles.
Sorry. Partly, it reminds me of a question that we often ask in interviews, which is, what is wrong with what you're working with? You know, someone will espouse their great skill in Python or C++ or something, and what's wrong with it? And if they say, oh, nothing at all, then it really does show that they're not really looking at it with clear eyes. And so I think that's sort of, in a software sense, that ties back to what John was talking about in terms of the thinking about the structure of where we're working in the context in which we're working.
Yeah, I understand the context. So I speak as someone who's about to inherit responsibility for IT as well as research computing. So I've had to give this a lot of thought. And one of the reasons that I agreed to do that is because to bridge that very gap. And just without going into details, so in the sort of team I'm inheriting in Norwich, currently there's a campus network team, there's a research computing network team or person, and they had to join up somewhere, but there's a lot of there had been in the past been lots of mistrust between the two and so forth. So yeah, there is a definite gap there. I'm a huge advocate of, as you say, digging in and finding out how things work and getting things working. But ultimately, we're here to support science, and I think that can be a big difference between kind of the scientific computing approach, which is how do we enable this for science, and the sort of traditional corporate IT approach, which is, well, we do this and that and the other, and actually, sorry, that's not this. So that needs, from my point in a research environment, that needs to change, and that's partly why we need to do it. But we'll see how it goes.
Thank you.
I wonder whether there's a time relation to this this difference in sort of skill and inclination between IT and HPC people you were describing there, John. Because I'm going to do the old man thing. I was old enough to be around in the era of 8-bit micros when I was a kid, and hacked on those, and got knowledge about computers and computing that way. And then in the UK, there was a big gap after that in terms of the cohort that came through. They were taught, IT in school was how to run Microsoft Word. And then when those people entered the job market, it's all about certification. So they're certified to configure a Cisco router, but not a Juniper router. Whereas, if you were maybe taught more or discovered more of the fundamentals, you'd say, oh well, this brand of Ethernet router is the same as this other one, is vaguely similar to this other networking technology, InfiniBand. The UK did come back with things like the BBC microbit. So I wonder if in 10 years' time, or 5 years' time, by the time the people who are trained that way come through to the job market, there might be a difference of approach.
It's interesting you say that, because I think my GCSE IT was just the mail merge and things like that. We had to do it right, but it was certainly not what I do now. I think that's one challenge at the moment. There is a gap, and one thing which I've noticed as well is hardware labs are disappearing, they're becoming more expensive to run, and that's a real shame, because that's often at universities. It might be the first time someone's got their hand on a network switch or whatever, a server or whatever it is, and it's sort of being replaced by go and program or go and be a web developer or something like that. And we do need to do that. I mean, I came into this, I was an academic, ended up in IT services, so it's that trying to bridge the gap between the two of them. We want secure, stable systems, but we also don't want to break research and teaching at the same time, and I'm constantly in the middle of that battle at times to try and make sure that works. But I fundamentally want research and teaching to occur in a safe and sustainable way. And if we do more of a teaching side, we'll get more people interested in this HPC environment, and then we'll get people who can sit here and we can be retired and chill.
This idea that by doing things better will make our lives easier, I take exception to. I think we track an ISO line of effort and being overstretched. And the better we get at doing stuff, the more stretched we get by doing more. And so everyone's permanently in a state of being pretty much at their capacity, and that's probably the equilibrium at which we always operate. And these tools will only ever enable us to operate at greater scale or at a higher level. It will still be hard work, unfortunately. That's my view anyway.
I was going to quickly go back to the point that Chris brought up about BBC Micro, right? So it's not all doom and gloom, because when we talk about BBC Micro and people hacking on stuff, we're probably just enough time on now from the Pi Foundation, where actually we had that same group of hackers that were playing around with technology and were working out interesting ways to do things. And they're going to be coming through now. So it's not all doom and gloom. I think we just need to look in the right places.
I agree. Sean, you have a question?
I want to be controversial. as usual.
No, surely not.
And Paul's going to hate me for this, but he's not in the room anyway.
No, he is right there.
Is or should, in this era of sustainability, should traditional data centers be disappearing and being replaced by modular data centers? For instance, a containerized data center is almost all recyclable, whereas a big physical infrastructure is much less recyclable. It's not like an office block where, I mean, we've got office blocks on sites that are 50 years old, 50, 60 years old. Once my data center's shut down, its reuse is less obvious, at least within a research environment. You can make it maybe into a big laboratory, but it's much harder to adapt to other use cases. So should we be looking more towards expandable, containerized environments, or should we continue with building physical data structures?
I'm happy to start as well.
Yep, Chris too. Oh, Chris.
Okay, I don't want to give my thoughts on this one. So I remember watching a video back in 2008 from Google, who did a tour of the data center. And when they said data center, I thought, oh wow, I got to see what Google's offices look like as well. And then when I saw the video, there was a tour of a warehouse. And it was a warehouse with containers and a crane that basically just dropped them in. And they maintained those containers just the same as any other environment would. But their ability of being able to scale out really quickly was massive, right? Fast forward to now, there are some organisations that are still talking about the ability of struggling to reclaim waste heat because they're going to have to retrofit their entire site to do it. That's not sustainable, surely. I would have thought the more sustainable approach would be to effectively have an area that is just like a warehouse, that allows you to have containers that you can roll in, ready provisioned, ready to go, that have already been pre-factory tested, that you can just then take a defined, say an ISO standard connection to it, that then can pump out that water, can pump out the cooling, and use that to waste transfer. But they should be standards, so that we can actually use those standards and repeat them in other places. Otherwise, everybody's creating a completely different way, a unique snowflake of a way to do this. When really we should probably be trying to work towards standards. And I guess the OCP is one of that, right?
Chris, did you have something to say?
Chris has already mentioned OCP, so that's fine.
Okay.
Well, actually, hang on.
Hang on, why not? Have your two penneth.
A couple of years ago, the office next door to us, they had the builders in, and peeking through the door, I didn't realise that they actually run a fairly sizable machine room inside an office block in the centre of Bristol, which really didn't look like the right way to go about things. And so I think those kind of approaches where you have essentially a sort of ad hoc data centre in the office next door, that's probably wrong, and maybe that's not the right way to go. But I do wonder with the containers. I mean, going back to the Dell study that I linked to in the presentation earlier. What is the energy that goes into making a shipping container full of kit? Because I don't think they're really intended to be made in order to be more sustainable, more energy conscious. Particularly, I would be interested to know how it works out compared to fitting out a building and operating that building for probably a considerably longer time. When the kit dies in your modular data center, do you have to replace like large parts of it, or I don't know? Maybe you just continue to operate the container with new stuff.
So I've looked at this in some detail before this. So the modular data centers are very efficient with the PUE, you write down, because they're mostly free air cooling. So they're really super efficient in terms of their operational power consumption. But they're kind of disposable units, so the lifespan is 15 years. Well, the Dell ones I was looking at was 15 years. So you get it, you plug it in, you rang it for 15 years, you throw it away.
But then they're almost completely recyclable.
Yeah, well, the most 95% of it is just the plant. There's not much building. There's no concrete.
Yeah.
So the carbon costs are low, because concrete is really expensive.
there's a slab, you have to put them on, but that just lives there, forever. So the carbon cost of the data center, of course you've got to ship it.
But you'd have had to ship kit anyway.
But there's a lot,
You'd have to ship the
the
bricks.
ratio of non-plant material is low compared to the rest of the building. So I think it's an interesting analysis that we can get Dell to do that. But I would think that the sunk carbon cost in the modular is lower than in a fixed build because there's nothing there apart from the plant.
That's good to know.
Yeah, I should say, I mean, it's something that for us, we did look at that. The advice we had that it wasn't the best fit for us. I can't definitively, obviously, a lot of it's horses for courses and some of that is what you want to be putting into it and scale and all sorts of things. But yeah, I think it highlights that these things are really complicated questions and there's probably no easy answers and it's maybe a bit of a get out. But yeah, I think it is something we did look at, and particularly if we were looking at kind of an off-site DR facility at one point when, and that was one of the options we looked at, it could have been a perfect fit for that as a sort of dropping container to somewhere else. It looks like we can actually have a reciprocal arrangement with another institution, which is even better if that's a facility that's already there. But yeah, these things are need careful thought.
Yeah.
I'm not saying we've made all the right answers, by the way.
Oh, no. I mean, I guess your situation is quite unique in that
I think, Chris, did you want to say something?
No, go ahead.
Yeah, sorry.
It's a bit of an awkward position because I don't want to say the opposite of what my director has just said, but to answer Sean's question, an alternative to the modular data centre would be to do what they did for Lumi. So they didn't build a new data centre, they had a brownfield site and they built a room inside it. That was a much more carbon efficient approach to the...
Even better idea. An even better idea.
So did you have some final words?
Yeah, sure. So I guess Steve, your situation is quite unique, right? And then you're able to build out a new environment, right? And so you can pretty much have the best of what you've got right now, and you can plan forward, and that's really good. I think for people like Chris mentioned, right? I think for people that have existing sites, there probably needs to be consideration for, and this sounds awful, but gutting the entire area. Right, and just completely wiping out everything inside that area to then refit something new. I think a lot of our deployments are very piecemeal. In that we say this is a data center, this is our location, we can't move out here at all ever, and then people go, well, we can't do half the stuff we really want to do in this location without having to refit and spend millions on doing it. When really we could just say, if we've got an existing building somewhere and we just said the idea was to just gut it and start with a shell, what would we do? That maybe fundamentally changes how we do stuff.
Thank you very much. Well, that guess that just about wraps it up for the panel discussion on sustainable computing. We've got some great grist for the mill there. Thank you very much to the panel for your incisive comments, and I'll pass over to the next speaker.